So welcome to the very first lesson of the course. In this lesson we're going to start learning about the basics of the C# coding language. Now learning the basics will not only get us started and move us closer to working with audio, but will also give us our first insight into the moving parts behind any video game. By learning the basics, we'll not only be able to use fundamental programming tools, but we'll also gain a new perspective over how video games operate and function behind the scenes. As we then progress through this course and you begin to learn more about programming and implementation in general, that perspective is going to grow. It's also something that I believe can be a very powerful tool in the hands of a music composer or a sound designer, because not only will you understand better how developers are able to mold and create their games using Unity and C#, but you'll understand how music and sounds can then fit that mold in a neat, organized and optimal way. Okay, so let's start our first lesson. Now, in order to start writing code, we first need a script. A script is simply a container for code that we want to write. Creating a script is nice and easy, but to keep things organized, we're first going to create a folder to hold all of our scripts in. So first, I'd like you to find your project tab, which for me is at the bottom of my page, and in the project tab, I'd like you to double click the scripts folder, and then inside this folder, I'd like you to right click on an empty space, select create and folder. Once you've done that, call this new folder my scripts. Now that we have this folder, we can open it up and do the same thing again to create a script. This time, right click, go create and select C# script. Now normally when naming scripts, we'd choose a name that would reflect its purpose, but seeing as we will be using this one solely for learning about C#, we'll just call it practice script, making sure not to include a space in the name of our script, as this can cause an error and our script won't work. Now remember that everything in the project tab we create reflects the files and folders that make up our entire Unity project. So by creating a C# script, we've also created a .cs file inside the folders of our Unity project, as well as a metadata file for it too. Now to open and edit this script, we can either double click on it, or we can right click on it and select open. And by doing this, we will be opening the script editor Visual Studio. Once Visual Studio has opened for you, you should be looking at something similar to what I can see now. So let's go through everything we can see and break it down. Now every line you can see is what Visual Studio provides for us by default when a new script is created. The best way to read code or scripts is by one line at a time, from top to bottom, as that is the order generally that our code will be checked and performed in by Unity. So let's start at the very top on line 1 and work our way down. Now our first 3 lines of code are referred to as namespaces, made clear by the fact that they all start with the key word using. Namespaces allow us to access certain information that we can use inside of our scripts. For example, the namespace using Unity engine allows our script to use and then interact with specific Unity components, such as a GameObject's transform component. Now if I quickly jump back into Unity and just select one of the GameObjects in our scene, you can see that it has a transform component at the top of the inspector tab. Now this component tells us where in the game world our game object is located, as well as a game object's size and rotation. So because our script has the using Unity engine namespace in it, we're able to access transform components and interact with them, as well as other parts of Unity that we'll be looking at later on. Now if we go back to Visual Studio, you may notice that there are 2 more namespaces above the using Unity engine one, but these 2 are highlighted grey. Now if your namespaces are grey, that simply means that there is nothing in your script currently that is using the information that these 2 namespaces provide us access to. So if we wanted to, we could remove these two top lines from our script, but we'll leave them alone for now. Now also notice how all three of these lines end with a semicolon. We can end a line of code using a semicolon like this in the same way we would end a written sentence with a full stop or a period, telling Unity that this line has finished and contains no further information. Other than that, we won't be looking too much more into namespaces until later on in the course, so don't worry about them for now. Now, underneath the namespaces, we have the beginning of our code. Now, whenever we create a script, we also create what's called a class of the same name. Now, a class is a container for the information and behavior that we create. They're used to create methods, functions, and variables, all of which we'll talk about later on. You can also create subclasses within the script's main class to contain and store more specific information and use as an organizational tool for larger scripts. Now notice that directly underneath this line we have a curly bracket. And also notice that if I highlight that curly bracket, we have a second one at the very bottom too. Now these brackets and the area in between them are known as the body of the class. Inside them is where we place any information and behavior that we wish to use inside our class. For now, we're going to ignore the word public at the beginning, as well as the colon mono behavior at the end, because we won't be changing them at all. So now that we're inside of the main class, we can start adding to our script. Now the first thing we're going to do is create something called a variable. Now variables are a very common tool that we'll be using throughout this course, as they are used to create and store specific information known as data. Now this data can then be used however we wish in our game. There are many different types of data known as data types. Each time we create a new variable, we need to tell it what type of data we want it to hold for us, such as numbers, letters, coordinates, and so on. Now, one of the most common data types is the integer type, used for whole numbers. Now, to create a variable of the integer data type, we first need to make some room in our script. So to do that, all you need to do is place your cursor at the end of line 6, just after the curly bracket, and hit enter a couple of times to make some space. Then the first thing we do to create the integer variable is write int, which is short for the word integer, followed by a name we would like to give our variable. So for example, if we wanted to use this variable to represent a player's health, we might call it health, like that. Then to finish creating our variable, we end the line with a semicolon. So now we've created a variable. This is also referred to as declaring a variable. Currently our variable is empty and doesn't contain any information. So let's give our health variable a value to hold. And whenever we want to give a variable a new value, we add an equals operator after its name, followed by a value that we want to give it. So I'm just going to give mine a value of 5. Now, giving a variable information like this to hold is referred to as initializing the variable. And just like that, we've not only declared our first variable, but we've also initialized it too. So to sum up, whenever we wish to create a variable, we declare it inside of our class, start with a data type, and follow it with a name that we can choose ourselves. We can then initialize that variable by giving it a value to hold. We do this by following the variable with the equals operator and then writing an appropriate value. So now, whenever we use or reference our newly declared health variable within the rest of our script, we'll be able to access the value stored inside of it as well, which is 5. Now, another common data type is the float type. A float is also used to store and hold numbers, but unlike the integer, it can store numbers with decimals. So for example, by writing float and then naming this variable something such as speed, we can then give it a value of, say, 0.5. We must, however, add after its value a lowercase f. Otherwise, Unity won't recognize the 0.5 as float data. We can also use the Boolean data type by writing the word bool, short for Boolean, which can only ever be set to true or false. So an example of a Boolean might be one that is used to check to see if the player is on the ground or not. So I could call this variable player is grounded. I could then set it to true, like that. And finally, the last data type we'll look at for now is the string data type, which can store characters and words. Now, to create a new string variable, we need to give it a name and a value to store in it, like the others. So we'll call this one color, for example. But we're also going to need to write the characters or words we'd like to store in quotation marks. So just like how float data must have a lowercase f after it, string data must always be in quotation marks. So let's say that I want to write the word red for this variable to hold. I have to make sure I have a quotation mark at the beginning and at the end, just like that. Now, alternatively, we don't have to set values to these variables straight away. If I were to write any of these without a value next to them, say for example the health variable, its value would become whatever the default value is for that data type. So integers, floats would contain a value of 0, booleans would be set to false, and strings would be set to a very specific value called null. Now, null simply means that the string variable is empty and doesn't contain any characters inside of it. For this practice, we're going to keep all of our variables holding specific values. So let's undo the last two changes we just made. We can do that by pressing Ctrl Z on the keyboard if you're on a PC, or Command Z if you're on a Mac. So moving on down our script, we next see some green text starting with 2 forward slashes. Now this is called a comment. This indicates that the following line won't be read by our script. Now you can use these to temporarily remove lines of code without deleting them, which you may do for testing purposes, or to write notes for yourself or to other programmers in order to help explain what your code is doing. Now in this case, this line is telling us how to use the next part of our script. And the parts underneath the comment are also very important. These are called functions, sometimes known as methods. Now functions basically do stuff. They follow instructions that we give them. They are used for many different purposes, such as making calculations with our data, performing behavior, or checking to see if certain things have happened in our game, just to name a few. We know these are functions based on a few things, so let's break them down. Notice how they both start with the word void. Now, like variables, functions can be of different types, but unlike variables, functions don't have to have a type. Void is used when declaring functions and tells us that this function has no type and is simply used to follow instructions that we give it. Now don't worry too much about the word void and what it actually means. We'll be looking at it in more detail later on. Now the next part of the function is the name, which in the case of our first one is start. We then have two parentheses or brackets which are used for creating parameters for our function. But again, we can leave these blank and not worry about them until later. Now, just like our classes, the last part of the function is the body represented by the two curly brackets. This is where we can put our instructions that we want our function to follow inside of. Now, it's important to note that these two functions we are provided with will behave in specific ways. Now, you may have heard of the term frames per second before when referring to games performance. Video games work by showing you a series of still images, one after the other, really fast, which creates the illusion of motion, just like an old-fashioned film projector would. These two functions are specifically used in Unity's version of C# to do whatever we tell them to do at specific frames. We're actually able to use these two functions thanks to the monobehavior part at the top of our class. Without it, the script wouldn't recognize these two functions and would give us an error. Now, the start function will only do what we tell it to on the very first frame that this script is active for, whereas the update function will on every frame that is run whilst this script is active. We can use other functions that behave differently, which I'll provide a link for in the bottom of this lesson. But for now, let's see if we can take some of our variables which we created earlier and change their values with these functions. Now, to start with, I'm going to temporarily disable the float variable, the Boolean variable, and the string variables we created and focus on the integer variable for this demonstration. Now, I can do this by either turning them into single line comments, which I've already done, or I can do this by writing / followed by a single star at the beginning of the section I'd like to comment out, and then at the end adding a star and a /. This is what's called a multi-line comment. Okay, so let's start by assuming that we're going to be activating this script or turning it on as soon as the game starts. Let's take our health variable and let's reference it in our start function by writing its name. We're then going to change the value of the health variable to 10 in the same way that we set it to 5 earlier on. So let's write equals 10. So by writing equals 10 and ending the line, we'll be changing the health variable from 5 to 10 as soon as the game starts. We can then test to see that this has worked by writing a very specific function, debug.log. Now, debug is the name of another class that the developers of Unity created inside of another script for us to access and use. Log is the name of a function that has been declared within the debug class, in the same way that the start function and update functions have been declared inside of our practice script class that we're editing now. Now, try not to let the fact that the log function looks very different to our start and update functions confuse you. They're all functions, and we'll be discussing why log is written differently in future lessons. Now, debug.log works by taking whatever we put inside of its parentheses and displaying that information into Unity's console tab. If I quickly jump back into Unity, the console tab for me is next to my project tab, which I can click there. So inside of the debug.log function, inside of the parentheses, let's write health. We then need to save our script and use our script in Unity. To save a script, you can either press Ctrl and S on your keyboard if you're on a PC, or Command and S if you're on a Mac, or you could go to File, Save Assets, and click on that. Once you've done that, you can then jump back into Unity. Now, the first thing you'll notice when jumping back into Unity is a little spiral in the bottom right corner, and possibly even a loading bar, like you've just seen pop up on my screen. Now, that little loading spiral tells us that Unity is compiling our script and checking that we haven't made any mistakes or errors before we can use it. If we had, it would have displayed an error message in the console tab, but seeing as it's still empty, we're all good to continue. Okay, so to use our script in Unity, we first need to attach it to a game object. So let's right-click inside of the Hierarchy tab and select Create Empty. Let's then make sure our game object is selected in the Hierarchy tab, and then in the Inspector tab, select Add Component, and then add our script to it. So our script was called Practice Script. There we go. Now, by adding a script to a game object, we've created essentially a copy or an instance of the original file. When our game is played, the practice script component that we've just attached to our object will point Unity to the location of our actual file we created within its assets folder for Unity to then run and process. So now that our script is attached as a component, we can run our game And on the very first frame, we should see the value of our health variable appear in the console tab. So let's press play and see what happens. There we go, the number 10 has appeared just like we expected it to. Now what if for some reason we wanted to change a variable on every frame? And to do this, we'd go back into our script and we'd use the update function. Now I'm going to demonstrate this by using the speed variable, so I need to quickly remove the / and the star icons from in front of it so that I can gain access to it again. So instead of just changing the number of its value, let's instead use an operator to change it. Now the main operators we can use work the same way they do in mathematics, where we can add, subtract, divide and multiply. So let's try adding 1.2 to our speed variable on every frame. Now remember, whenever we want to assign a new value to a variable, we need to write the variable's name, which is speed, followed by the equals operator. Now that we've done that, we then need to write the name of the variable again to tell the code that we're going to take whatever value the speed variable is currently at, which in our case is 0.5, and then add 1.2 to it. So let's then write plus 1.2. Again, because this is float data we're using, we need to include a lowercase f after the number, and finally a semicolon 2. Now a good way to understand what is happening here and how our code interprets this information is to read it out loud to ourselves as if we were commanding our code to do something for us. Now in our case, that command would sound something like this. On every frame that is run in our game, take whatever value our speed variable is currently at and change it to whatever the value of the speed variable now is, plus 1.2. Let's again add the debug.log function to test that this has worked. But to make things a little clearer for ourselves, I'm going to write inside of the function, in quotation marks, player's current speed, followed by a colon, and then plus speed. The text inside the quotation marks will be printed as they are and won't change. Now this is just a simple way of labeling in the console what those numbers we're about to see every frame actually mean, and you can write whatever you want. We then include a plus sign in between that and the variable we want to see the value of to tell the function we want to see two pieces of information. Now if we wanted to, just like how by writing the variable speed we get its value, we could create a string variable like we did earlier and store the words player current speed in quotation marks inside of it and just reference the name of the string in the parentheses of our debug.log function instead, and it would work just the same. But for now, let's just save our script and go back into Unity to run our game. So let's quickly press the clear button in the console tab to clear it, press play and see what happens. And there we go, we can now see that it's worked. Every frame that is run, our speed variable is changing value. So that's how we can both change the value of a variable and use Unity specific functions to do so. And with that, we'll stop there, as we now have a good, strong understanding of some of the very basics of C# programming. Now, the most important things to understand from this lesson are variables and functions, as they're the cornerstone to any coding language, and we'll be using them a lot as we continue. Remember that a variable can create and hold data for us. We can then use functions to take variables and the data that they hold and do whatever we want with them, such as change their values like we did in this lesson. It's this relationship that we'll be using a lot to play, stop, change, and manipulate our audio later on. So once you feel confident with variables and functions, head on over to the next lesson where we'll look at more ways of manipulating our variables with functions, as well as some more things we can use inside of our scripts.